Hey everyone, welcome to my talk on Dockerfile do and do nots. There are many ways to skin a cat, but should you is the question. Just first, a little bit about me. I'm Melissa McKay, I'm a developer advocate at JFrog. I'm a Java champion and recently had the honor of becoming a Docker captain. There is my Twitter link here and my LinkedIn information is here if you want to follow me or reach out and ask questions. First of all, I'm actually a cat owner. These are my two friends that my kids and I rescued as feral kittens last summer when we were all stuck at home. I call them our pandemic pets or our COVID kitties. So for those who read the abstract for this talk, this is not a presentation about actually skinning cats. As you can see, these two are alive and well. Instead, this presentation will include a bunch of cute cat pictures because who doesn't like that? And I'll be going over some of my early experiences with Dockerfile development. All right, the Dockerfile. With the Dockerfile, you have all of these building blocks that you need to get your application out the door and into production. This is a fairly exhaustive list of the commands available to you in a Dockerfile, and with these, you can pretty much do anything your heart desires. You can do all the right things, the wrong things, and everything in between. I did post a link here that describes all of these commands if you're not familiar with them, or if there's some here that you haven't seen before and don't use today. We're going to explore 8 do nots together. These are things that I learned through trial and error myself when I first got started with Docker. And many of you may be aware of these pitfalls already, but my hope is that you'll find 1 or 2 of these useful and think about making some edits to your existing Docker files that you have in the wild right now. And just to set the stage, several years ago, I was brought onto a project that was initially developed by a third-party contractor. This project was brought in-house for a small team to manage and maintain, and you guessed it, I was one of those team members. So before I was a developer advocate, I was a developer in developer land for about 20 years. So this wasn't new to me. However, Docker was very new to me. When I first started, this was the first thing I ran into, ignoring the dockerignore file. I didn't even know that this existed. So of course I didn't use it. And maybe some of you haven't used it either. Definitely consider getting this done. One of the things that annoyed me the most in the project I was working on was how long it took just to build my images. Every time I made just a tiny change, it seemed like it took forever to build. And I didn't fully understand how the Docker context was working in the background. That was the real issue. This is a contrived example, but it includes that exact problematic line that we had in our Dockerfile at the time. See that copy instruction on line 3? Clearly, that is copying everything in my working directory. And at first, I thought I could improve my build time by explicitly copying only what I wanted, but under the covers, everything is still shipped to the Docker daemon, even if you don't end up using it in your image. For this particular project, it was taking forever because there were a lot of huge images and video stuff that was happening in the background. And all of that test material was being shipped to the Docker daemon, and I didn't realize that, even though I didn't intend to copy that information into the image. That's other reasons not to ignore that dockerignore file. Don't be adding test material or specific user files or even secrets that you might have stored locally. Those can very much end up in your final image in production if you aren't careful. And if you're curious, this is an example of a dockerignore file. Notice that .git directory, that was another thing I didn't think about, that I was actually throwing all of that into my image as well. Passwords obviously didn't need to be in there. The second line, just in case you aren't familiar with it, it is basically the first line is saying don't include any of those types of files except for the README. Go ahead and include the README. So that's how those first 2 lines work. All the matching in the dockerignore file is done using Go's filepath.match rules. And you can also, there's some obvious filters in here already, but you could also ignore the Dockerfile and the dockerignore file too, if you wanted to. They will still be sent to the Docker context because you kind of need those for, you need those in order to get everything to work, but they won't end up in your final image. All right, using untrusted base images. I'm going to confess, when I first started ramping up on Docker, the first thing I did was follow the README instructions for getting the source and then building. That was it. I just wanted up and running as quickly as possible. I didn't realize how base images worked until later when our build broke with an error message saying that our base image no longer existed. And it turned out that the base image in our Dockerfile was actually getting pulled from a private repo of the original third-party contractor, which had been out of the picture for almost a year by then. A problematic base image probably isn't going to be named something as obvious as evil image, but my point here is just to pay attention to where your base images are coming from. These images are dependencies, and as such, they should be pulled into Artifactory or the like and managed along with all of your other binaries that you rely on for your build. Consider starting with Docker official images. Docker has a dedicated team that's responsible for reviewing and publishing all of the content in the Docker official images, and this is all public information, so you can see very clearly what's actually going into those. Those teams work in collaboration with upstream software maintainers and security experts and the broader Docker community. All right, never updating. How many of you are guilty of this or have been on a team where keeping your software updated isn't a priority? And it's really easy to fall into that idea of if it's broken, don't fix it, especially when you're hurried or you're pressured for time, but there needs to be a balance. Just waiting for that build to break before doing your updates is not a good strategy. And why? I'll give you 3 reasons. Security updates are important. Security updates are really important. And I'm serious, they're really, really important. Block out time during every development cycle to spend on this kind of maintenance. If you find yourself not having time or not wanting to do these updates, you definitely, there are other problems going on in the team. So definitely figure that out, assign some time for every development cycle to get that done. Some believe that not defining versions is a good way to get the latest of everything and keep your software updated, but that leads me right into the next pitfall. This one, not defining our versions, this one kicked us as you would expect. Our build just randomly started breaking one day. This is another contrived example of what we had going on, and see those package installs? At some point, there was a package that had an incompatible update, and it took way too long for us to figure out what the problem was and which package it was and which versions we had before it was broken. You should always have a bill of materials for your build. Know what version of everything is installed. JFrog Artifactory has metadata called build info, which is super helpful with this. And save yourself some time by eliminating those multiple moving parts and control your version updates. Specify the versions, and during your maintenance windows, that's the time when you should be planning for experiencing a possible breakage rather than when you're trying to get a delivery out the door. Including build tools. This is something that I see a lot, especially as a Java developer. I've seen this. We include Maven, we build the project in Maven, package it up, and then go ahead and run it from there. This works, it does, but the size of your image will be a lot bigger than it needs to be. You also have a problem with now your attack surface is larger than you would expect. You should minimize your attack surface area by only including what you need for your application to run in production. And one way to do this, it is good to include the specifics of how your project is built in the Dockerfile. And I want to make that point clear because this makes it buildable, this image buildable by anyone, regardless of availability of tool sets in a local environment. So to get around this and get the best of both worlds is to use those multi-stage builds that are available. This way you get a smaller image and you don't include those build tools in the end in your production image. Using external resources. I really like this picture of the kitty chasing this butterfly because that's exactly what we were doing in our Dockerfile. There's a little bit of paranoia here, but I'm going to explain why this was such a problem. So if you have an external resource, which in this particular example, do you see the second run statement? It's running curl and it's grabbing this script from somewhere. What if that goes away? What do you do? And that's exactly what happened to us. We weren't the maintainers of this particular script. It was for some proprietary software that we needed, and we would download and install it every single time we would build this image. Not reviewing that script in the beginning was pretty risky. No one took the time to grab that script to see what was in there. So that is a pretty big window for a supply chain attack if there was some malicious intent there and that script was updated without anyone's noticing. So if you must use a script like this, use the pull once, keep forever methodology, because you really should be pulling stuff like this into your environment, storing it in Artifactory, for example, so that you can control the versioning and you aren't at the whim of the script owner or the maintainer. All right, 7, hard coding secrets or config. This problem is pretty obvious. Your images are going to land in multiple places, multiple environments, multiple development machines. You don't want to pass around that sensitive information because it'll spread like a disease, and your only recourse once it's out there is to invalidate it and start over. Even if you know you shouldn't be putting in passwords and stuff, there is one scenario that you might not think of right off the bat, and that's the fact that sensitive information could still be in your image in lower layers. Although that's not easily accessible, they're still there. See that third line? That was a naive attempt to get rid of some sensitive information that was coming from the base image. That doesn't work. That base image is still there. That layer still exists. That data is still in there, even though it's not immediately visible to you if you were to exec into the container, you can still get to it. Other configuration information might not be quite as sensitive as passwords, but it's best to keep your images environment agnostic so you aren't in the business of creating separate images for separate environments. This means don't put in IP numbers, don't put in specific locations for specific external resources. Make sure that that is all configurable and lives outside of your container. All right, lastly, when you're new to Dockerfiles, it can be pretty easy to fall into the trap of treating your Dockerfile as a glorified shell. And our Dockerfile was doing quite a lot and doing too much, really. This is another contrived example. there are several problems here, and we had some crazy side effects from what we were trying to do in our Dockerfile. The first one was there was a package coming in from the base image that was old, but we weren't able to remove it from the base image because we no longer had access to the base image. So instead of rebuilding the base image, as you should do, the idea was to kind of hack our way around and just remove that old package and get an updated version later. That's not the best way to do things. You get a huge image that way because remember that old layer still exists. The next problem we had here was, see that line at the bottom, the run cleanup database script? That was pointing to an external database and making some changes, doing some test prep, and then running unit tests. Well, what happens if you run unit tests and they fail? The next time you build, let's say you go in and fix your unit tests, the next time you build this, it's not going to clean up the database because it's cached. So that's not really the best way to do things. Building containers that have side effects, you should not have side effects like that when you're building a container. You can do it when you're running the container. That's perfectly acceptable and okay, but not during the build. All right, that is it. Those were the top things that I struggled with during my first few days learning to write Dockerfiles. I've included some resources here as some things that we talked about. The Dockerfile documentation, official images information about multi-stage builds, and also you're going to need to store these images somewhere. So I do have a ref card out on dzone that just talks about considerations to make when you're choosing a container registry. All right, thank you, everyone. I appreciate your time.
Thank you, Melissa. This was fantastic. Thank you so much. We actually have a little bit of time if you want to answer some questions live.
Absolutely.
Questions there, so feel free to stay on until you have to leave. So yeah.
Okay, cool. All right, so I'm scrolling back because I'm not seeing anything in the Q&A. Where are the do's? The do's are don't do the don'ts. There's some advice on how to avoid situations like some of the examples that I gave. I like this, Kyler. I'm unfortunately doing like all of these. Yes, I expect that is the case for a lot of folks that are using Dockerfiles right now. Anyone else have any other questions? If I've missed it, just go ahead and put it in the chat and I will answer. How to protect secret in default Docker build. Well, one way to deal with secrets is you can store secrets like in an external volume. You can use a something like Vault. Use variables inside your Dockerfile and pass the secrets in rather than have them stored in the Dockerfile or in the image. Those are some ideas on how to protect your sensitive information. Default user usage. Yes, that's a huge one. Running as root. That is a huge problem because when you realize that containers are actually just Linux processes, just like with a few restrictions. If someone gets access to your container and it's already, your application's already running as root, they also have access to everything else and they can wreak havoc on your host in that case. So usually what I recommend, if you're running an application, assign a user, create a user within the Dockerfile and use that user to run the application. Developer secrets manager, yes, very good. That is very good. how to put a wait time for when building 2 images. For example, I'm using Compose to create MySQL and Python. I need MySQL to be up before my Python is built. There's some scripts out there where you can wait. They're kind of hacky, but there is a way to wait. You might have to write something like request information from your MySQL database to make sure that it's up and running before you continue. Yes, sleep. You could do that. All right, anything else? I don't want to keep everyone from the main stage either, so I'm going to go ahead and sign off here. If there's 1 or 2 questions still lingering out there, let me know. Is it possible to configure environments? Absolutely. I have seen, even for like, getting base images from different container registries, depending on which environment you're in, I've seen, that being passed in as a variable instead of being hard-coded in the Dockerfile. And that's one way of doing that. As far as one last thing for configuring environments, just make sure that the configuration is run when the container is running. You can set all that up at runtime. It doesn't need to be involved when you're building the image to begin with. All right. Where can we find more content from you? Well, I'm a relatively new DA, so I have content slowly coming out. Definitely follow me on Twitter. I'm at Melissa J. McKay on Twitter, and my LinkedIn information as well. I'll go ahead and put these slides. I'm not sure how we're making slides and stuff available, but I'll make sure that they are available somewhere for you, even if it's just in Sessionize or something. Yes, that is my Twitter. All right, thanks everyone.